Morning students, today we'll see about the fourth unit, sewage treatment and sludge treatment. So here you can see the general overview of plant components, sewage treatment plant components. So here you can see the wastewater coming from the source, and there is a preliminary treatment and primary treatment and secondary treatment, and the last is disinfection. So here preliminary consists of it removes the grits, oil and grease particles, sand, silt and grit particles, oil and grease particles. Here there is a screening. Then after this treatment, the sludge we can use it to usually to send to the landfills. After that primary treatment. So here there is a clarifier we'll use. Then the secondary treatment, biological treatment system. Here there is an activated sludge process and trickling filter process. After that, disinfection process. So in the primary treatment also we have clarifier. So through the clarifier, there will be the primary sludge comes from. Then secondary clarifier after the secondary treatment, it deposits the secondary sludge. All this sludge is taken to the treatment, and after that it disposed. That is a sludge treatment. So in this fifth unit, it consists of two parts. One is the sewage treatment and the sludge treatment. After the sewage treatment, there is a disinfection process. That means to kill the pathogenic bacteria. So this treatment we also call as biological waste water treatment. It is used to remove the suspended solids and the dissolved organic growth from the wastewater by using microbial populations. So the microorganisms are responsible for degradation of organic matter in this. So this is also called as biological treatment. So here this biological treatment classification of microorganisms based on the oxygen content. So here you can see chemical form of carbon required microorganisms are classified as autotrophs, heterotrophs. We all know autotrophs, they can synthesize their own food. So organisms that use carbon dioxide are HCO3, and heterotrophs that are use carbon from organic carbon. So there are phototrophs, chemotrophs, and the temperature range. Based on the temperature range, the bacteria which survive, it is classified into three types: psychrophilic bacteria, mesophilic, and thermophilic. So the organism whose growth is optimum within the temperature 15 to 30 degrees centigrade. And the mesophilic optimum temperature is 30 degree to 45 degrees centigrade. And thermophilic 45 degree to 70 degrees centigrade. The organism will grow within that temperature. And the organism again it is classified based on the oxygen for their survival. It is aerobes, anaerobes, and facultative organisms. So anaerobes, the organisms that use molecular oxygen, usually DO, for their metabolism. So what is meant by metabolism is breaking down of complex substance into simplest form, as we all know. Then anaerobes bacteria, that organism, some molecule other than molecular oxygen, they use it for their metabolism. And the facultative bacteria, which may present or absence of oxygen, it can survive. In suspended growth process, so if the microorganisms are suspended in wastewater during biological operation, then this process is known as suspended growth process. That is called activated sludge process and aerator sludges. Recycling of settled biomass, that is sludge, is required. Then attached growth process, here the process in which the microorganisms that are attached to the surface over which they grow is known as attached growth process. That is trickling filter. So in activated sludge process, it is in suspended form, and here it is attached growth. There is a difference between trickling filter process and activated sludge process. There, activated sludge process, the bacteria are in suspended form in wastewater treatment, and here there is a attached growth. So rotating biological contractor RBC, the biomass attached to the media, example rock, plastic, wood, we can use as media. The recycling of settled biomass, that is sludge, is not required, but recycling of sewage may be done here. Combined process is consist of both attached growth as well as suspended growth process. So, for example, trickling filter and ASP and trickling filter are facultative methods. Here in this picture, you can see the trickling filtering process. So here we can use the filter media as rock or plastic media. So bacteria feed on BOD and base. So it get attached on this. Here you can see the attachment of bacteria, the organic matter attached on this. That media that is called as zoological slime. It form a glimpsy photofilm that is called zoological slime. So here you can see the trickling filter process. The wastewater enters here. So on the top it is aerobic bacteria which consumes the organic matter. Then when it penetrates after this layer, so anaerobic bacteria consumes and it degrades the particles. So microbial slime layer is formed here. Then again it goes to wet media. So here there is a circulation of air. So that's why presence of oxygen, aerobic bacteria, it undergoes decomposition. It takes place the decomposition and anaerobic bacteria after the treated water comes down. So as the wastewater trickles through the media layer, a film is formed. Around the media is called slime layer or biofilm, as I said earlier. So the depth of the aerobic zone is within the slime is 0.1 to 0.2 mm. The remaining part of film is anaerobic. So as the wastewater flows over the film, the organic matter is rapidly metabolized, while colloidal organics are absorbed onto the surface. So here you can see trickling filter. There is a rotating arms. So through this, the wastewater passes to the media. So here aerobic anaerobic process takes place and the remaining wastewater comes here. So there are different types of trickling filters. Low rate trickling filter or standard rate and high rate trickling filter. Here you can see in this tabular column what is the difference between the low rate and the high rate filter. So everything it varies from the hydraulic loading and the organic loading. So here in the low rate, the rate of filtration is very low. If you take from the starting loading, it's a 1 to 4 meter cube per meter square, but in the high rate filter 10 meter square per meter cube per meter square. And the depth also varies 1.8 to 3.0 meter here. But high rate filter, the depth is very low, but the filtration process will be high. So this picture shows the filter trickling filter. You have to draw this and you have to mark the parts and you have to explain if it is asked in exam, but it is very important. So this also shows the section of the trickling filter. So here you can see sprinkler, filter, feed pipes, all these are components. So rotating arm, filter media and the drainage system. So you can see the filter media, the size, it may be 25 to 75 mm, and you can use the crushing shell, crushed rocks we can use, and the plastic media, and filter media, it may be of different shape. So the depth is 1.8 to 2.4 meter, and there is this picture shows the under drainage system, and the under drainage system blocks. So there is a perforated blocks used in collecting channel. Function is twofold to circulate the air. So here it collects the sewage from all the under drains and convey to next unit. So there is a filter floor and filter walls, ventilation, floor distribution. So here you can see the elevation of the trickling filter. So like this, in practically, if you go any treatment plant, you can see this. Okay. So here they gave the design part. So design they are not design in depth. Only you should know what is the trickling filter, what is process, what it process, and what are the types of trickling filter and the components in the trickling filter. Okay, besides stop, next class we will see the phenomena elaborate. Just only I gave introduction. Next class I will show the detail. We'll see activated sludge and trickling filter. Thank you.